Hello millennials and Gen Z. In the last video, we are looking a model with single neuron. In this video, we are going to look a model with two neuron, nearly with the same example. Equation it's going to satisfy is y equal to 2x. So according to that, the input data is like for input x is 1, output is 2, input is 2, output is 4, input is 3, output is 6. That is 2x. This is, if this is x, 3, 2x, 3 into 2, 6. Yeah, so it's like in input that is 1 neuron. It passes its value to the 2 neuron. Then again 2 neuron gives produces here the single value in the output. But here we need to see, like previously what happened with a single neuron is responsible to generate the output, but now this two neuron is responsible to generate the output. And the weight, the main thing is the weight over here. So these weights gets adjusted in such a way that the combination of this w1x1 plus w2x2 produces the result. So example is same. Result is produced by the combination of these two neurons. Everything is same, like learning is w minus gradient into learning rate. Learning rate is 0.01 in the example over there. Definitely we are going to change it to 0.1 and 0.01. Error is again the same, y dash minus y. Gradient is d by dw of error. Everything is same. Let's look into the code. Code is also the same as the previous one with single neuron, with some minimal other changes. Import is same. There is only one difference over here is we take the activation function, that is torch.nn.function.f. This extra import for that. Now the name of the class is two neuron model, same as nn.module. Here previously we see there is only one layer with one input and one output. Here we see there is here we introduce one hidden layer, one hidden layer and one output layer. In hidden layer takes one input and two output, and in output layer takes two input and one output, like this. So this is two layer we have created over here. Now the two layers arranged in the forward method like this. Inside the first whatever the value we pass over here, it passed to the hidden layer with which input as one element and output with the rel function as two element. Now two elements goes to the output layer and it generates a single output. Let's parallelly run that as well. So we run this in time, no time, basically 0 seconds. Yeah, that's fine. Now we initiate the model, two neuron model over here like this, and then we create the loss function from the NN module, that is a neural network .msc, mean squared error loss, and then we initialize the initiate the optimizer SGD, stochastic gradient descent, learning rate with 0.01. Let's run this as well. Okay, now we have instantiate thing, model, loss function and the optimizer. Let's run it and print to the screen and see what's there. Okay, so two neuron model is like this. It tells about the structure, one hidden layer and one output layer. In hidden layer takes one input, in feature is 1, out feature is 2, bias is true, in feature is 2, out feature is 1. Loss function simple, it says loss function, and in optimizer it shows its learning rate like 0.01, maximize false, momentum 0. Definitely these are the properties that we can set in the optimizer as well when we go to the advanced tutorial of this. For now in the beginning we just play with the learning rate. The input is x equal to 1, 2, 3. Regarding 1, output is 2. For 2, output is 4. Yeah, so it is y equal to 2x equation. It creates the training data creates the equation y equal to 2x. Definitely we see the other data as well, one more data as well, like 1 to 2, 2 to 3, 3 to 4, like this, so that we can see a single model can train to any data. So for here, now this training goes on here. We take the 500 epochs like previous, clear the optimizer, forward pass. For the model we give the x, basically x is this, the complete batch, not the single element. We get the y prediction. Now the loss, we give the loss function, we calculate the loss, y prediction, and y loss dot backward. It performs the back propagation and calculates the gradient. Once the gradient is calculated by the loss function, optimizer, we use the optimizer dot step to adjust the weight. So weights get adjusted. This is for every 100 iteration. It's going to print the loss, what is the loss over there, and weights. So in weights, now there are two elements over there in hidden layer. So it is going to, yeah, we have print the hidden weight. So basically the combination of that weight produces the respective output, and that is trained. So if we yeah, so now single neuron is trained over there, and its value should be 2. We know that, right? So that y equal to 2x is when x is 1, y is 2 into 1 is 2, x is 2, y is 2 into 2 is 4. Now here scenario is different. Now here, with the help of 2 neuron, it is going to predict the output, the same output, like for 1 to 2, 2 to 4, and 3 to 6. So let's run it and see what's the combination over there. Definitely initially all the weights get initialized randomly, but after the training it approaches to a particular number, so that it can generate this type of data. This model can generate this type of data. If we give 1 to 2, 2 to 4, 3 to 6, similarly we give 20, it needs to give the 40. If we give 30, it needs to give 60, like that. So let's run it and see. Yeah, so here is the output over there. Initially what happens is there is 2 weight, the error is 0.09, then error gets reduced, right? Error gets reduced to 0.001, means nearly no error, right? This is a very small value. Error gets reduced completely. So initially its weight is like point of one neuron weight is 0.67, other neuron weight is 1.5. Definitely the value generated by these two combination is not the proper value. So this weight gets adjusted during the training, and as we have print out this in every 100 iteration. So yeah, this after 100, this after 200 iteration, this number gets increased to 0.74, and this 1.15, this number is also get increased to 1.2. Now 1.74 to 0.78, 1.2, like this. Now let's test the model. So during testing, if we give it 4, what here needs to print is, it needs to print 8 as per the training, right? We have given the training to the model to print the double of the number, as we have trained the model with this data. So basically model needs to be trained whatever data we are trained with the trained to the model work according to that only. So here let's see, 4 is going to generate 8. Let's run it. Yeah, so here we give 4, the number is 8.0126, which is very accurate, very near to accurate. Instead of 8, it's 8.016. definitely it's not perfect, but it is always near to the perfect. Suppose we try with some other number to check the model, like 20, it needs to give 40. Yeah, so 40. Now this is not with a single neuron, right? So there is 2 neuron work over here with different set of weights, like one neuron weight is 0.8, another neuron weight is 1.2. So this is working with the two neuron, and yeah, this is working with the two neuron. Let's do something different, like let's change the input and output, and again read, and again we are going to train the model, then see what's the result going ahead. Like one gives 2, that's correct, no problem. 2 gives 3. Now 3 gives 4. Let's increase one more number over here in the training. 4.0 gives 5, right? 5.0. Okay, so this is the training data. If we train with this data, what the model prediction is, if we give some number like 77, it needs to give us one more, means 78. Let's train it with this data. First we need to run this block. Okay, x and y gets changed. Now we train with this data. Yeah, so we see the loss function. Oh, loss function is 0, means now it's going to be perfect. So initially it's 0.67, one neuron weight is 0.66, 0.88, 0.97 to 0.88. Yeah, so this neuron weights gets adjusted. Now if we give the same value 20, what should be the output? Output should be, if we give the 20, output should be 21. Let's see. Yeah, it gives the output is 21.032. That's the perfect. So in the two neuron, the different than single neuron is, definitely example is same. So the difference is basically this two neurons combined produce the same result. So in single neuron, we need to change the weight of only one, but here we need to change the weight of two, right? This weight and this weight. So basically when here the error gets generated, suppose predicted value is other than the exact accurate value, like if we give input as 2 and after the neural, after passing through the neural network, it's come over here and it generates, let's say 8, but it needs to generate the 4. So 8 minus 4 is 4, so 4 is the error. Now 4 is the error. With this error needs to calculate the loss function, needs to calculate the gradient over here. So with the help of that error, gradient gets calculated, and this both two neurons gets adjusted. But the main question is, definitely we can generalize it, like here two neurons are there. It may be 10, it may be 10,000, right? So how do we know which neuron needs to be adjusted by what number? Means one neurons get, definitely all the neurons will not subtract with the same number or like that, because combination of this is generating some output. So we need to adjust these all weights such that the combination of all is going to produce that correct result. So how do we know what is the number we need to subtract or add from every neuron weight so that it will give the output correctly? It's by that error calculated. With that error, it is going to perform over here is d error by dw. Gradient is calculated. So main logic is in gradient calculation, which program does internally within PyTorch library. Definitely we are going to see the principle how the gradient is calculated. So with the help of this gradient, we know what value we change in the weight, that change the error. So we calculate the gradient, and then appropriately we change the weight like this. So all the weight gets changed, and all the weight contributed to produce the errorless output, like this training with the multiple neurons. Yeah, that's is all in this video. Thank you very much. Have a good day.